Yeah. Yeah, the last one is about the hydrogen and also the syngas. Because for the past few days we keep discussing about the liquid fuel, solid fuel, liquid fuel and also solid fuel, liquid product and solid product. So today we would like to discuss about the gas product, which is start with syngas first. So how we going to implement or utilize our waste management in order to get the syngas. So waste management, waste treatment, we have many methods. So we have the very typical method which we dispose directly for the landfill, disposal directly for the landfill. We of course the environmental impact, very serious environmental disaster. So we also have the currently in many countries. We also have the incineration plant, which we burn it directly, but it will produce the greenhouse gas. But now the incineration plant is already improved. They can recalibrate some heat to generate some electricity, but still burning. So the greenhouse gas will be produced. But most renewable way or the new way, the latest way is more on what the biological treatment or the thermal treatment, which we are keep discussing these few days. So the biological treatment normally we will get the biogas, the biogas. Then the thermal treatment we can get the syngas, and both this biogas and syngas is contain of what the hydrogen gas. So this the hydrogen gas is currently focusing. We are focusing now because the hydrogen. Why is focusing on hydrogen gas? Is one of the future fuel. Why the hydrogen is a future fuel?
No emissions.
Yeah, first is no emissions during the combustion. Yes, correct. No emissions during, and also the high energy. High energy value per unit. Yeah, it's high energy value. So it the current focus shifts to the hydrogen energy. But before we go to the hydrogen energy, we look at the syngas first. Syngas. What is the syngas? It's a synthetic gas. Go through the as I told you. Go through the go through the thermal chemical process from the biomass. So the main product will be the CO and also the hydrogen. Sometimes it will produce some methane also, and also the CO2. So normally, this is normally is from the organic waste, which is the biomass. Most of the biomass is produced 40% of the hydrogen, maybe 30% of the CO, and some percentage of the methane gas, and also the other type of gas. So this is the syngas. So the pathway for the syngas. So after you produce the syngas, what you can do for the syngas? Okay, normally the syngas will be produced through the gasification process, thermal chemical conversion, but mainly due to the gasification process. When I talk about the thermal chemical process, the pyrolysis process will produce the syngas as well. But as I discussed yesterday or the day before, the pyrolysis process, our main product is what? The bio oil or the solid product. But no doubt the syngas will be produced as well. But for the gasification process, their main purpose or main aim is to produce what? The syngas. Then what you can do after you get the syngas? So first, the syngas can be converted into the methanol, and also the syngas can be go through the generators and also the boiler directly to produce steam and power to generate the electricity. Directly. Then this one to go through the genset or to go through the internal combustion engine, or can go through the your fuel cell. Then syngas is the hydrogen. This hydrogen, they are more application for the hydrogen. You can use in the fuel cell, and also the transportation. We have the hydrogen vehicle, then can go through the refinery as well, and also the hydrogen power plant as well to generate the electricity as well. So and if the syngas go through the freezer throat, this is a very typical technology to convert into the diesel or the green diesel, green diesel or the gasoline products. Then for the methanol, of course, for the methanol, we have various applications as well. Then can we produce the ethanol as well. So this is what the syngas is important, because they have many other applications. But how we going to get the sustainable syngas? That is another problem. So this is a question. So how much waste is there to be treated? Because keep treating, how much to be treated? What type of the waste? What type of waste you want to treat? Because different type of waste, maybe you might use the different technologies. So what is the chemical composition and what is the calorific value? Because if we want to use the syngas as what? As a fuel, right now. Mostly you see most of the application is we use as a fuel. So what is the calorific value or the energy content for the waste? So what's the particle size and moisture, etc. So the waste that can be treated is many things. The municipal waste or the commercial waste, sewage waste or the agricultural waste or the tire waste and etc. So how much is to be treated and how we can get this sustainable feedstock or raw material, or we need to consider. To be asked before we continue. So when we talk about the thermochemical treatment, so there are two types of the biomass. One is the biological and one is the non-biological materials. Because some of the non-biological material have relatively high energy content. You know why is that? The plastic, the plastic waste, the plastic waste. And generally, you see the plastic waste have the very high heat content or the energy content. So that's why currently many people they try to convert those plastic waste into the syngas or hydrogen gas. So for the biology waste, it's just like the our agricultural waste, our food waste, and this and so on and so forth. With the average heat content, heat value is maybe half of the total non-biologic. So yeah, and let's see how which one you want to convert. Yeah. So the thermal waste treatment. This one I already discussed. So they divided into the three categories as usual, with the pyrolysis we keep discussing yesterday and the day before. So for the syngas, basically we go through the gasification because your background, your hydrocarbons in your biomass waste into the syngas by control amount of the oxygen, by control amount of oxygen with some oxygen. So normally, typically, the temperature is happen around 1002, starting from 1002 to 1006 for the gasification. Then for the pyrolysis, with the average temperature of the 500 plus minus 500 degrees C. So their main product is what? The char oil. Of course, the syngas we produce as well. Syngas we produce as well. Then this one is combustion. Combustion directly we throw it into the what boiler or whatever to generate the heat and electricity directly. So yeah, that is fuel pathway. But in order for us to get the syngas, the gasification is a preference. Gasification is a preference technology if you want to get the syngas. So this is the what? This is the main chemical reactions go through the gasification. Just now is mentioned why we need some amount of the oxygen. So where is the oxygen come from? So normally for the gasification, we put in some steam, heated steam, so that heated steam to have the H2O, so that they can react and can generate what? Hydrogen. Our main product we focus on more on hydrogen. Of course, the CO will be produced. So just I mentioned, CO and hydrogen are the main products. So yeah. So this is the one of the example of the biomass go through the gasification. So normally we have air or steam, either the air or steam. This one is using the air directly to provide with the O2. And sometimes we can use the heated steam, which is H2O, because it's pushed towards to produce the hydrogen from the heat there. Then we have the raw syngas, and first stage of the clean up of purification. Then go to a second stage, and we can get the hydrogen. Then some of the CO or other type of the syngas can be produced as well. Then the pure hydrogen can be used in what? In the fuel cell and also the hydrogen vehicles, fuel cell or hydrogen vehicles. Then the syngas can go through the plant to first is to generate or this one is generate electricity and this one go through and generate electricity directly, or go through the process plant to have some liquid fuel or the green diesel or green gasoline, green diesel or green gasoline. Then after that, it can the recovery waste heat can go through the boiler. Then we can have some with the CO2 separator. We have some exhaust gas and or the CO2 can store the CO2 for the commercial purpose. Then go through the steam turbine and generator to produce the electricity. So this is one of the very typical gasification process, which the main aim might be produce the hydrogen, but other byproducts can be used as different applications. So yeah, that is about the syngas. So what we want to focus is the hydrogen gas, correct or not? So hydrogen gas. Why hydrogen gas? Why hydrogen gas? This one is I also obtained from one of the study from India. As I told you before, hydrogen energy or the fuel cell energy already discovered in 1800s. In year 1800s, we already know how to produce the hydrogen and how we going to use the hydrolysis process 18 years ago. But still, we didn't utilize the hydrogen until now, because during that time, when, if not mistaken, is Sir Henry, he discovered the electrolysis process. Henry William, if not mistaken, I don't know, you can check that. Henry William for the electrolysis process. Then during that time, they want to use the fuel cell, they want to use the hydrogen, but make it clear why, because sooner and later we discovered oil and gas, which much more efficient, and then no need any costs, can be obtained with no any costs, because during that time the hydrogen and also fuel cell is one of the energy sources. So until today, we still are not using. So because why? Because how we going to produce the totally green energy? Because if you want to go through the electrolysis, what is the electrolysis? Anyone still remember? Because during high school you learn about the electrolysis, right? What is about electrolysis? Yes, separate the hydrogen and oxygen, right? You need what? You need electricity, to separate the H2O, to separate the water from water. So you need to provide with the electricity. So electricity, so we still need some electricity. So how we going to produce the green hydrogen? That is the question. So that's why make it the electrolysis process is not working just until today. So yeah, but currently many government including this one of team I just mentioned obtained these studies from one India. They mentioned that the India want to have the energy independence like 2047. I'm not sure. I'm asking you. Yeah, it's my question to you. Then to achieve the net zero by 2070. Is it true?
Yeah, that's a plan.
That's a plan, That's a plan. Yeah. Because this one I've taken from one of the studies from Indian scholars. So yeah, that's a plan. So that's why. I'll start from that time. Then from time to time, we found out that the hydrogen energy have more application. Just like what I mentioned just now. We can have the fuel cell vehicle. Then we can have the hydrogen. What do you call it? Hydrogen fuel station and hydrogen plant directly. We can generate the electricity from hydrogen power plant from power plant directly, and we can use the green energy to produce the hydrogen, which we can convert. You see, some of the country or the region rich in the solar, so they are unable to store their solar, right? Currently they just store in battery, but the capacity for the battery storage is limited. But no doubt this is one of the very good storage medium. Then in Australia, how they store it? In Australia, they have very big land with solar energy. So how they store their energy? They store their energy in terms of fuel. Instead of the battery, because battery is very heavy and hard to transport in terms of fuel. So they convert the solar energy, the surplus of the solar energy, they will go through the electrolysis, then to produce the hydrogen and store the solar energy in terms of the fuel. So this is one way of the storage of the energy. So that's why we have the solar power hydrogen. So yeah. So the growth trend, because currently I guess all of you already know, mainly focus on the European country or IEA. They are focusing more on the hydrogen energy, including the Japan, Germany, and US. These three countries are the top consumption of the hydrogen energies compared to other. But the hydrogen currently is play a very important role in energy transition, because now we are in the energy transition. Like what I mentioned, so currently the industry 4.0 took place. So what is the energy, sustainable green energy that can replace fossil fuel to reduce the emission? Yeah, hydrogen energy might be one of it. So yeah. So this one is to give you a brief idea. How much hydrogen energy can be produced from the different type of the waste or raw materials. For example, the municipal solid waste can produce around 80 kg of the hydrogen. 1 ton of the biomass can produce 50 to 100 kg. You see the capacity is less than 10%, less than 10%. So yeah, currently then the plastic is the highest. The plastic is the highest. So people tend to convert the biomass from the plastic into the hydrogen, because why? It's here the highest. So now people is trying to coal process or coal gasification with the plastic waste, to produce the hydrogen energy. So industry waste also 50 to 100. Yeah. So yeah, this is the technology to produce the hydrogen. This one is not all the green technology. I just show you all the potential technology that can produce the hydrogen. Currently, our hydrogen production mainly depend on what? Natural gas. Still from the natural gas, which from the basically from the methane. Methane go through what? Go through the steam deforming, steam methane deforming process to get the syngas and to get the hydrogen. Because this is currently most sustainable methods. So what they do on that, because this is not green, right not from the fossil fuel, but currently I can say at least more than 70% of our hydrogen are from this process. Currently what they do, because what happened? What happened to the steam methane forming? Anyone know? Steam reforming from the methane.
It probably depends on natural gas resources.
This is one thing, but we have abundance of natural gas. You don't worry. Because more and more oil and gas plant recover. So yes, 20 years back, people keep saying the oil and gas will be decreasing and reducing, but not nowadays, because no one saying this thing anymore, this segment anymore, because there are more and more oil and gas plant discovered. But we are shifting to the green energy due to what? The emission factors, emissions. Because why? Because the steam deforming process will produce a CO2. That cannot be avoided. But this is a very effective process to convert the natural gas, which is the methane into the hydrogen. No doubt. So currently, what they are doing with the steam reforming, they just put the carbon capture, unit to capture the CO2. But many typical plant they still are using just the normal steam reforming. So yeah, these three. So currently the hydrogen gas mainly depend on the natural gas and also the coal. Coal is what? Coal why? Because some of the countries they don't have any oil and gas, so they are producing their hydrogen gas using the coal. For example, like China, they have abundance of coal, but lack of the oil and gas.
How is the yield using oil and gas?
I'm not sure it's very high, because oil and gas, natural gas, methane, is a CH4. CH4 is totally, can say, it's very efficient. Only the methane then can produce the hydrogen directly. So it's a very high CH4 and to phase 2. It's very high. So it's currently the world is producing by using the hydrogen. But now, back to our question. What is the sustainable pathway to produce the hydrogen? We can go through the biomass. This is the topic that we want to discuss. The biomass from biomass materials. Then the biomass materials, there are two pathways. One is the biochemical conversion, biological conversion to get the biohydrogen directly, or can get the biogas. Biohydrogen and biogas. Then go through the chemical conversion process like gasification process. We also can get the syngas. Gasification process can get the syngas as well. So algae from the sunlight, then go through the biochemicals, it can produce the hydrogen as well. Then the solar and wind go through the secondary electricity, and then through the electrolysis. This is the electrolysis. Go to the green electrolysis, then can produce the hydrogen as well. So this is the potential pathway. Later on, I will show you what is the color of the hydrogen. Color from hydrogen, from very dark color until the green color. What is the process that for that?
Sir, is it energy intensive to separate hydrogen out of syngas?
This is another challenging. So that's why people prefer to use a natural gas. No any other type of the biogas of CO or whatever. Because it's a very pure hydrogen from the methane. Natural gas are particularly from the methane. So that's why if we are to go through the biomass, a lot of the other gas can be produced. it makes us very hard to separate as well. This is another problem facing by the biomass gasification process. Yeah. Even though go through the biological process, the hydrogen here that can get less than 10%. Imagine less than 10%. Biological even less, but from the gasification maybe still have 10%. Yeah, 10%. But biological definitely will be less than 10%, maybe 5%, or even lower. Some of the process even lower. Yeah. So you see, in order for us to produce the green hydrogen, we must have the overall ecosystem. First, we must have the totally green production process. Right? Not start from green production process to produce the hydrogen. Not only look at the end user and also the power generation only. End user and power generation only, because end user and power generation, because we know that when we use the hydrogen to turn into the energy, definitely is very clean. It's very clean. But the thing is, how we can have the sustainable green hydrogen production after it produced. Storage another issue. Transportation is another issue as well. This is all the boring that we need to break through, and also we need to develop this whole ecosystem so that we can have the sustainable green hydrogen. And after that, I go to the end user. Yes, end user, no problem. I mentioned during a consumption, very green. And after that, from this, then we can generate the green electricity or power, and so that we can have the totally green hydrogen for the overall life cycle or ecosystem. If not, you are green in the end user or the consumption part only. How are you going to produce the green energy? Yeah, that's the thing. So the first challenges is coming. Storage. This one, storage. Because the production technology, just now I briefly show you, a lot. Correct not? And the main challenge comes. Storage. You see. The storage. The storage in the gigajoule of each fuel, you see. For the hydrogen, this one is this oil hydrogen, liquid hydrogen, compressed hydrogen, compressed with different pressure, compressed with 700 bar and 350 bar. You see, the storage is very small compared to the diesel and petrol or diesel. So storage, that's the thing. Storage of 1 kg of the hydrogen, you see. I need 1,001. Then if not, you need to compress it. If not, you need to store it at a negative liquid, negative 200 something degree. Why negative 200 something degree? Hydrogen in what form? During the atmosphere temperature or ambient temperature? In gas, right? In gas form. So that's why. The volume for gas is very big, right? Compared to the liquid and compared to the solid. So that's why we need to know this one. Move back to the fermenter. So this is the phase diagram for the hydrogen. You see here. For the degree C2 to C3, it is in the gas form. Up to the 10 bar. You see, if we want to at the atmosphere pressure, we want to maintain it at the liquid form. We need to give it negative 240 and below. If not, we need to compress it. This liquid, this one is compressed. For the gas form, very high pressure. So that's why. So that's why the storage is one of the issue. Yeah. So is what the compressed and liquid. We have these two are typical method. One is the compressed gas. Another one is the liquid part. Multi-window negative 280. 280 80, which is 80 degree, lower than the liquefied natural gas. That's why need very low temperature and compress. Need to compress up to 350 to 700 bar. That's why it's very high compress. So that's why. So now there are many studies also starting to find what is the suitable. I think I mentioned it a few times last few days. Storage material for the hydrogen. So now many studies they found I found some certain materials. Certain material can store the hydrogen, good material, but how they going to extract? Store and extract. That's the thing. So another way that we can store is we convert the hydrogen to another form. So that's why people tend to convert into the methanol. And after that, when you want to use, then we come back.
During the consumption.
During the consumption. So that's why you see, fuel cell. You know the fuel cell unit. Normally, we are using the hydrogen because H2 plus oxygen equal to H2O. Then the energy are regenerated, right? No? But now we have the methanol fuel cell because methanol is easy to carry, easy to store. So that's why we can use the methanol in the fuel cell also during a consumption in the fuel cell. We can use the methanol directly as well. But if you use the methanol, it means the C and CO. CO and CO2 will be produced. Yep. C and CO2 will be produced. Correct. So yeah, these are challenges. The first challenges. Yeah, correct. And storage, no doubt. And in study also, this one. Structured hydrogen with a very high pressure. So we need to find the suitable materials that can store the hydrogen. So this is the transportation. Just now I mentioned transportation. You see, in order to transport 1500 gigagram of the petrol and LPG, only you see 2.2 truck, and this one is 3. But you see, for the hydrogen, you need how many? Even this one compressed to 700 bar, 30.4. This one is compressed to 250, double. Yeah, this one. And this one is liquid form. Liquid form. That's the thing. Yeah. So storage and also the transportation is the main issue facing by the hydrogen energy. So this is the hydrogen production. Maybe a break for 15 minutes, and we come back with the hydrogen production technology. So there are different types of the hydrogen production technology. Okay, any questions before we take a break?